Integrated rate equations are obtained by integrating differential rate equation. R0 is the initial concentration of the reactant, R is the molar concentration of the reactant after time t. First order reactions are those whose velocity is directly proportional to first power of the molar concentration of the reactant. Half-life period of a chemical reaction is defined as it is a time taken to complete half of the chemical reaction. Hello everyone, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, the third session of chapter Chemical Kinetics. Third session of the chapter Chemical Kinetics. In the previous session, that is in the second session of the same chapter, I discussed about two terminologies. First one is order, second one is molecularity. In that order, I discussed about zero order, first order, as well as pseudo first order reaction and unimolecular, bimolecular and trimolecular reactions. In this session, that is in the third session, I am going to discuss about integrated rate equation for zero order as well as what? First order reaction. I am going to derive or explain about integrated rate equation for zero order reaction, first order reaction, significance of first order rate equation and half-life of a reaction Today in this session, I am going to discuss about first one, integrated rate equation for zero order, integrated rate equation for first order, as well as significance of first order rate equation. Third point, I am going to discuss about half-life period of a chemical reaction. Okay. Now, let us consider integrated rate equation for zero order reaction. When you consider, so V is equal to K into molar concentration of A to the power of X and molar concentration of B to the power of Y. In place of Y, if I put D of molar concentration of R dt is equal to K into molar concentration of A to the power of X and molar concentration of B to the power of Y. In place of V, if I substitute minus dr by dt, then that is called as what? Differential rate equation. This expression is called as what? Differential equation. If I integrate the differential rate equation, I will get integrated rate equation. How can I get integrated rate equation? Integrated rate equations are obtained by integrating differential rate equation. Okay. Now, let us consider. So, first one, case 1, zero order reaction. Already you know that what are zero order reaction? Zero order reactions are those whose velocity is directly proportional to zero power of the molar concentration of the reactant. Whose velocity is directly proportional to zero power of the molar concentration of the reactant. That is, so the reactant is independent of molar concentration of the reactants. Zero order reactions are those whose velocity is independent of molar concentration of the reactant. Let us consider a zero order reaction of the type R give rise to P, which takes place with velocity V. V is directly proportional to zero power of the molar concentration of the reactant. V is equal to rate, which can be written as minus dr by dt, is equal to K into molar concentration of R to the power of 0. When I remove the proportionality sign, is equal to K, and in place of V, you put minus dr by dt, that is decrease in the concentration of reactant. Okay. So, any number to the power of 0 is equal to unity or 1. Therefore, rate is equal to minus dr by dt k into 1. K into 1. Therefore, if I take negative sign to RHS, dr is equal to minus k dt. Dr is equal to minus k dt. Okay. Integrating the above expression. So, integral of dr is r. K is constant, integral of dt is t. After integration to the answer you have to add I. I is called as what? Integration constant or constant of integration. Integrated constant or constant of integration. Once again I will repeat, my dear student. R give rise to P, let us consider zero order reaction with velocity V. V is directly proportional to molar concentration of R to the power of 0 because it is a zero order reaction. V means rate. If I remove the proportionality sign, is equal to K into R to the power of 0. Rate is minus D of molar concentration of R divided by dt. So, rate is equal to minus D of molar concentration of R divided by dt is equal to K into 1. Take negative sign to RHS and integrating the above expression. Integration of dr is r, integration of k is constant k, so dt is t plus I. I is integrated constant. When time is 0, that is, I am not yet started reaction. When time is 0, the concentration of the reactant, the molar concentration of the reactant is equal to R0, It is what? R0 is the initial concentration of the reactant. Substituting T is equal to 0 and R is equal to R0 in equation. In place of R you put R0 and in place of time you put 0. You will get I is equal to R0. Substituting this value in the equation 1, molar concentration of R is equal to minus KT plus R0. Further simplifying equation 2, we get the rate constant K as R0 minus R divided by T. Therefore, the integrated rate equation for zero order reaction is R0 minus R divided by T. What is R0? R0 is the initial concentration of the reactant. R is the molar concentration of the reactant after time T. Now, I'll compare, take equation 2. Molar concentration of R is equal to minus KT plus R0. This with Y is equal to mx plus C. In place of Y, we have molar concentration of R. In place of X, we have time. And y-intercept is R0. C is called as what? Y-intercept. Y-intercept is R0. And slope is equal to, in place of slope, M is equal to minus K or K is equal to minus slope. Slope of diff. We'll get a straight line with the slope minus K when I compare the equation 2 with a straight line, general form of straight line, that is y is equal to mx plus c. Okay. So, what you have to plot? Along the y-axis, you have to take concentration. Along the x-axis, you get what? Time. We get a straight line with negative slope. That is, slope is equal to minus k. As well as with y-intercept R0. Therefore, what is the integrated rate equation for? What's the integrated rate equation for zero order reaction? The integrated rate equation for zero order reaction is K is equal to R0 minus R divided by T. Now, same integrated rate equation for which order? First order. What is first order reaction? First order reactions are those whose velocity is directly proportional to first power of the molar concentration of the reactant. Zero order means whose velocity is directly proportional to zero power of the molar concentration of the reactant. First order means whose velocity is directly proportional to first power of the molar concentration of the reactant. Let us consider a first order reaction of the type R give rise to P with velocity V. V is directly proportional proportional to molar concentration of R to the power of 1. Why I am going to put 1 here? Because it is a first order reaction. Because it is what? First order reaction. Rate, V in place of V, rate is equal to minus D of molar concentration of R divided by dt is equal to K into molar concentration of R. Okay. Now, if I take negative sign to this side, so it is nothing but what? D molar concentration, D of molar concentration of R divided by R is equal to minus K dt, is equal to minus K dt. Integrating this, okay. So, integral of dr by R is equal to minus K into dt. Integral of this term is log natural R. Integration of this term is log natural, ln means log natural molar concentration of R minus integral of K is K, integral of dt is T plus I. I is called as what? Constant of integration. Constant of what? Integration. Okay. Next. So, similarly, when time is 0, as previous derivation, when time is 0, R will become, molar concentration of R becomes R0, where R0 is the initial concentration of the reactant. Substituting in equation, wherever there is molar concentration of R, you put R0. Therefore, log natural molar concentration of R become log natural molar concentration of R0 minus K, time is 0, I. Therefore, I is log natural R0. Substitute this value in equation 1, will get log natural molar concentration of R is equal to minus Kt plus log natural R0. Rearranging, you take Kt to LHS, log natural R to RHS, you will get Kt is equal to log natural R0 minus log natural R. K is equal to 1 by T log natural R0 by R. Convert log natural to log to the base 10. Log natural means log to the base E. Convert log to the base E to log to the base 10. How do you convert log to the base E to log to the base 10? By multiplying by 2.303. By multiplying by 2.3. Now log natural is converted into log to the base 10. Therefore, the integrated rate equation for first order reaction is K is equal to 2.303 divided by T log R0 by R to the base 10, where K is velocity constant, T is time, R0 is the molar initial concentration of the reactant, this is molar concentration of the reactant after time T. For 0 order, K is equal to molar concentration R0 minus R divided by T. This is the integrated rate equation for which order? 0 order, and this is integrated rate equation for what? First order reaction. Okay. So, integrated rate equation. How can you get integrated rate equation? Integrated rate equations are obtained by integrating the differential rate equation of 0 order reaction as well as what? First order reaction. Now, what is the significance of first order rate equation? Consider when it is in the log natural form, while deriving integrated rate equation of first order reaction, in between we got one expression, log natural molar concentration of R is equal to minus Kt log natural of R0. If I compare with y is equal to mx plus c, in place of y we have log natural R, in place of x we have t, time. Therefore, m with what? Negative slope. M is equal to minus k, and y-intercept, c is y-intercept. In place of c, we have log natural R0. Therefore, first graph 1 for first order reaction is plot a graph of log natural molar concentration of R or log natural R versus time. We get a straight line with slope minus k as well as y-intercept log natural R0. Next, the first order rate equation, k is equal to 2.303 divided by T log to the base 10 molar concentration of R0 divided by molar concentration of R, rearranging log of R0 by R to the base 10 is equal to Kt divided by 2.303. Kt divided by 2.3. Let us consider log R0 by R to the base 10 is equal to KT by 2.303. If you compare with y is equal to mx plus c, y is equal to mx plus c, in place of y we have log of r naught by r to the base 10, log r naught by r to the base 10. In place of x we have t, therefore second graph is plot a graph of log of r naught versus r, 2 versus time, and y-intercept is 0. Y-intercept C is 0. Therefore, we'll get a straight line which passes through the origin. Why you get straight line which passes through the origin? Because here y-intercept is 0, and in place of slope, slope is equal to k by 2.303. Slope is equal to k by 2. Here slope is equal to minus k. Here slope is equal to k by 2.303. Therefore, for first order reaction, we have two graphs. One graph is in the terms of log natural, another graph is in terms of log to the base 10. Whatever it may be, along y-axis, always we have to take concentration. Along x-axis, we have to take time. Okay. So, for first order, we are going to get how many graphs? Two graphs. One is straight line with negative slope. Another one is straight line which passes through the origin. When you are going to get straight line with negative slope, when you plot a graph of log natural r versus time, when you plot a graph of log r naught by r to the base 10 versus time, you will get a straight line which passes through the origin with slope k is equal to 2.303. Once again, if I brush up the integrated rate equation of 0 order as well as what? First order. 0 order, let us consider r give rise to p with velocity v. V is directly proportional to r to the power of 0. V is rate, which is equal to minus dr by dt is equal to k into r to the power of 0. It is equal to 1. So, minus rate is equal to minus dr by dt, k into 1. So, dr, take negative sign to right side, it will become minus k dt. And dt to RHS, integral of dr is equal to integral of minus k dt. Integral of dr is r, k is constant, integral of dt is t. After integration, you have to put I, that is called as what? Integration constant. When time is 0, the concentration of R become what? R naught. Substitute wherever R is there, you put R naught. Wherever the time is there, you put 0. Therefore, R naught is equal to I. Substituting I value in the equation 2, in place of I, we put R naught. Therefore, rearranging, we will get K is equal to R naught minus R divided by T. Plot a graph of concentration of R versus time, we get a straight line with negative slope minus K. Like what's the integrated rate equation for 0 order reaction? R naught minus R divided by T. So, for first order, the integrated rate equation is K is equal to 2.303 divided by T log R naught by R to the base 10. So, what are the two graphs? One graph in terms of log natural R versus time. Another one is log R naught by R to the base 10 versus time. Half-life of a reaction. You already know about half-life period of radioactive element. Radioactive elements also have half-life period. Similarly, chemical reactions also have half-life period. What is half-life period of a chemical reaction? Half-life period of a chemical reaction is defined as, it is a time taken to complete half of the chemical reaction. Time taken to complete half of the reaction, or time in which the concentration of the reactant is reduced to 1/2 of its initial concentration. 1/2 of its what? Initial concentration. For example, so concentration is R, some molar R, when it will become molar R by 2 in some time, then it is called as what? T-half. Or half-life period of a chemical reaction. Therefore, half-life period of a chemical reaction can be defined in two ways. One is the time taken to complete half of the reaction, time taken to complete half of the reaction, or time in which the concentration of the reactant reduced to half of its initial value, half of its initial value. It is represented by T half or T 50%. It is represented by T half or what? T 50%. Like we derived integrated rate equation for zero order as well as what? First order. Similarly, now I am going to derive half-life period expression for zero order as well as what? First order reaction. My dear student, once again I will repeat, what is half-life period of a chemical reaction? Half-life period of a chemical reaction is defined as time taken to complete half of the reaction, time taken to complete half of the reaction, or time in which the molar concentration of the reactant is reduced to 1/2 of its initial concentration. 1/2 of its what? Initial concentration. It is denoted by T half or T 50%. Half-life for zero order reaction. Half-life for what? Zero order reaction. To derive half-life of a zero order reaction, you have to take integrated rate equation, what I derived earlier. Okay, you know that first one let us consider zero order reaction. What is the integrated rate equation or rate constant? K is equal to R0 minus R divided by T. Half-life period means in place of T you put T half and R will become R0 by 2. At half-life period, what I expressed? Concentration of the reactant is get reduced. So, half of its initial value. Therefore, molar concentration of R is equal to R0 by 2. Substitute these values in equation 1. So, in place of T, you put T half. In place of T, you put T half. R0 is there. In place of molar concentration of R, you put R0 by 2. Okay. So, 1 R0 minus half R0, it gives rise to R0 by 2. And if I cross multiply, T half goes here, K comes here. Therefore, R0 by 2K. R0 by 2K. Therefore, T half is equal to R0 by 2K. 2K for which order reaction? Zero order reaction. From the above expression, it is observed that half-life period of a zero order reaction is directly proportional to initial concentration of reactant and T half is inversely proportional to velocity constant. It is clear that T half for a zero order reaction is directly proportional to initial concentration of the reactant and inversely proportional to the rate constant Directly proportional to initial concentration and inversely proportional to rate constant. Therefore, T half-life period of a zero order reaction depends upon two factors. What are the two factors on which half-life period of a zero order reaction depends on? First one, initial concentration of the reactant. Second one, velocity constant. Next, half-life period for first order reaction. For the first order reaction, K is equal to, already know that integrated rate equation of first order reaction is K is equal to 2.303 divided by T log of molar concentration of R0 divided by what? R to the base 10. Okay, let it be integrated rate equation of first order reaction. At when T is T half and molar concentration R is half of its initial value means initial value is R0 by 2. So, the equation 1 becomes in place of T, you put T half, in place of molar concentration of R, you put R0 by 2, in place of R, you put R0. R0 cancel, it will become log 2. Log 2 is 0.3010. When I substitute in place of log 2, 0.3010, if I multiply 2.303 into 0.3010, it is 0.693 divided by K. 0.693 divided by K. 0.693 divided by K. It can be obseen that for a first order reaction, so when you consider half-life period of a first order reaction, the expression is 0.693 divided by what? K. It neither contain initial concentration term or not, neither in the numerator nor in the denominator. Therefore, for first order reaction, half-life period is constant and it is independent of what? Initial concentration of reacting species, as well as it is inversely proportional to K. Inversely proportional to K. Therefore, T half of zero order reaction, T half of what? Zero order reaction, T half of zero order reaction directly proportional to initial concentration of the reactant. But T half of first order reaction, T half of which reaction? First order reaction is independent of initial concentration of reactant. Initial concentration of what? Reactant. Therefore, first order reaction does not depend upon the initial concentration of the reactant. It depends only on velocity constant K. But zero order reaction, they depends upon R naught as well as K. They are directly proportional to R naught as well as inversely proportional to what? Velocity constant. Now, when you consider, today I derived integrated rate equation of integrated rate equation. First one for zero order. First one for what? Zero order. Zero order is equal to K is equal to initial concentration of reactant and molar concentration of R divided by T. For first order, K is equal to for first order, K is equal to 2.303 divided by T log R naught by R to the base 10. R naught by R to the base 10. These are two are called as integrated rate equation for zero order reaction as well as what? First order reaction. Zero order reaction as well as what? First order reaction. Similarly, I derived half-life period of zero order reaction as well as what? First order reaction. T half is equal to initial concentration of R divided by 2K, and T half for first order is 0.693 divided by K. This is for zero order. This is for zero order as well as it is for what? First order. So today I derived two integrated equations as well as two half-life period expression, one for zero order, other for what? First order. On this formula, you have numericals. You have numericals for both board as well as for competitive concern. You have to refer these four formula. First one, integrated rate equation of zero order reaction. Second one, integrated rate equation for first order reaction. Third one, half-life period of zero order reaction. Fourth one, half-life period of first order reaction. You have to learn numericals on this formula. Okay. Next session, I'll come up with numericals regarding about this integrated rate equation of zero order as well as what? First order, as well as half-life period of zero order as well as what? First order reaction. Next session, I'll come up with this topic, that is in the fourth session of your chapter Chemical Kinetics. Today, so I finished about all integrated rate equation about zero order as well as first order, half-life period of zero order as well as what? First order. Thank you. Goodbye.